Moving average strategy is fairly common in algorithmic trading, but in previous videos that I've done, we've looked at it as a vector backtest where we take one set of parameters and we test those parameters on the entire, I guess, data of time series data. So there are other ways we can improve our moving average strategy called walk forward optimization. And it would be helpful if you're not familiar with how moving averages work, but it's in a very fast, quick overview. You take two averages, rolling averages, and when those lines cross over each other is when you would put in an entry and an exit. So when we go to optimize it, a walk forward optimization splits our data into several different sections, and then it will test parameters on one section, test it on the next section, and then adjust its parameters. And in the end, we'll have something where we have tested a bunch of different types of parameters, uh, different averages windows, and we'll be able to calculate like which set of parameters gives us the best strategy over time, given the split of sections. So we'll still use VectorBT, and it's all pretty much the same imports that we used in our last moving averages um, video. So let's wait for this to install and get everything imported. We'll only be able to test this on a single symbol at the moment. I'm going to try to figure out how to do it in future videos for for like a portfolio, similar to how we did it previously. And then we'll just take the last 5 years and then download our prices. So we have the price of Apple for the past 5 years. So that was 2020. Now this is where we split our pricing into different sections. So we have our in these are like our tests are like how we're going to validate, or excuse me, our in prices and indexes are going to be the variables we use to test the parameters, and then we're going to um, excuse me, let's back up. I'm getting way too far ahead of myself. The in prices and in indexes are the training. The out is the testing. Sorry, it's been a while since I've been just doing this for so long. It's just like stuck in my head. But and then we set our window length of 2 years. Um, yada yada yada. Okay, so then really what's important here for this video is these functions where we simulate all the parameters. So we take what we typically use for VectorBT to run a moving average, and then we calculate the entries and exits, and we put that in a portfolio, and we return the Sharpe ratio. So when we pass through our pricing data, our window, and our other arguments, it will simulate all the different, it's going to simulate our price and windows for those moving averages, and then return the Sharpe ratio of that portfolio. This just takes these are two helper functions to grab the best indexes and also the best parameters for those Sharpe ratios. And then this is going to be our final function that passes through when we've grabbed the best and slow windows. We'll put in our price as well as the other arguments, and it will run again. It'll simulate the moving average using our best parameters and return the Sharpe ratio for that. So the way we calculate which ones to get our best windows here, we just put an array of windows that we're going to do here, and then pass it through our whoops, I didn't actually, there we go. So it's going to use all of our windows that we use here, and it's going to simulate all the parameters and return back the Sharpe. So this windows is actually an array, and I'll show you what it looks like. And so we're using simulate all parameters. So it's going to take the windows and it's going to calculate a fast and moving average for each window combination and return the two variables, and then calculate an entry exit, calculate the portfolio, and return the Sharpe ratio. So now in Sharpe is our Sharpe ratio, but this is the array of windows that we passed through, and it's checking which one of these creates our in best index is not defined. Why did I have this here? Because I need to get it first. So let me show you what in Sharpe does that look like. So this is our data frame that's returned to us when we simulate all the different parameters, and you can see the split index and which Sharpe ratio gives us the best one. So with these, so we have basically a huge data frame using a bunch of different window variation combinations for fast and slow that gives us different Sharpe ratios. So from this data frame, we want to get the best ones, best, fast, slow, the index, and Sharpe ratio. And so that's what these do down here. And then once we have our in-best window pair, and that's looking at the index, we have which one is our best fast and slow. So I should be able to actually call in best windows pairs to take a look at what it is. So these are the best pairs for our windows, and we're now going to basically test them on our out prices using our in best windows to get our best out test Sharpe. This might take a little bit. Cool. So now we have this here, and we've passed through our basically when we've calculated our windows and the best pairs that have performed best on our in-sample training, we want to now test it on our out-of-sample prices, whether or not these windows work on which index, right? And you can see that a lot of these are negative, but a better way of testing whether or not our in-test parameters perform well on out of set testing data is to do a p-value test statistic. So we're going to pass through our values, and the idea here is if the t test is going to tell us which whether or not from our data frame the averages of our Sharpe ratios are positive or negative, and then the p-value is basically our hypothesis, and our hypothesis here is that our our training parameters are going to perform well on our data that our algorithm hasn't seen before or hasn't trained on. And so the t statistic here is negative 4.9, suggesting that the average of our Sharpe ratio is negative here. And you can see we have a p-value of 0.999999, right? So in the combination here, this p-value is saying that there is a statistically significant suggestion that our in-sample training parameters do not perform well on our out-of-sample test data. So in this case, we would need to reject that our algorithm would perform well on data it hasn't seen in its training. So this is a really good way to both optimize our moving average strategy and test whether or not the parameters that we've optimized for would perform well on an on data that the algorithm hasn't seen or trained on. And this is a really good way to help prevent you implementing optimized strategies that you think, well, I've optimized it, I've even tested for the best window variances, and I've tested for the best sections, in my back tests. Therefore, I'm automatically going to assume it will perform better um, on data in the real market. And this would help you realize that deploying a strategy would not be a good thing for you in this case. So I hope all this was helpful. I'm hoping to make another video using moving average strategy on more than just one symbol here, on taking it with a portfolio. Um, and if you're, want to support me, you can get this code in the description. And then if you click on this little link, you can, drop me a one-time donation or do whatever you want there to support me. It really helps me out. It keeps me from taking sponsors or selling a course, which I think is a little overrated here on YouTube. So I'm just trying to stay away from it. Great, guys. I hope I'll see you in the next video. Until then, trade safely.